Hey everyone, today we will be focusing on our first hash table problem, focusing on implementing a map to construct a hash table. And without any further ado, let's get started. So now we are tasked with the following problem. We will now implement a hash table with separate chaining using the following and state differences for each. We are first going to build a hash table using a map. Then we're going to be building a hash table using an unordered map, and then using a hash table with an unordered multi-map. And the next phase, what we will be doing is that we will be using a set to be able to build our hash table, an unordered set to build the hash table, and then an unordered multi-set to build the hash table. We will insert a key value pair into the hash table, retrieve the value associated with the given key, and finally remove a key value pair from the hash table. We will print out our hash table's elements accordingly while we are updating this. And now let's go over our first problem. So overall, what we will be doing is that we are going to be focusing on developing our hash table using a map. So overall, the first thing we need to do, as usual, we are going to import our necessary libraries that we are going to use. So aside from iOS Stream, I'm also going to include a map, and I'm going to include a vector. Now, a vector is actually a useful tool that we use in C++. It allows us to be able to take elements and be able to actually use them to loop through our given data structure to be able to output and print and or delete or move. It's able to put all of our elements in a list accordingly. And there are really two parameters that really go inside of a vector, but I will go further in depth as we move forward. So, first thing I'm going to do, we're just going to be using the main function just for the sake of time in particular, because these libraries have already been built out for us to be able to call upon and use the principles of the hash tables accordingly, so that way we know exactly what to do directly, and we can just interface and just put them directly inside of our main function. Saves us so much time versus just building out everything from scratch here. And also do not forget using namespace std. So the first part that we're going to do is that we're going to first initialize our map. Our map has two parameters by general principle. I'm going to put in a string and an integer, and I'm going to call this omap. There we go. And then we will insert key values. So I'm going to go omap. And since we have a string, we're going to go 1, hence the quotations, equals to 1. Right here for the integer. And let's also be sure that we have the requirements. Insert key value pair. We're going to do that. I'm going to put 2 more as well. So 2, and then 3, 2, and 3, and we will retrieve the key. We will retrieve the value of the keys, and we can just work with 1. So I'm just going to put out value for 2 in that case. Map. And then all we got to do is just call upon from right here. Simple in this case. Then we're going to remove a key value pair from the hash table. And so I'm going to do remove key value pair. And what I'm going to be doing is omap dot erase. And we can just call upon the string that we have over here. And we will output our hash table, and we'll do this by using a vector for pair string int, because we are taking into consideration the parameters we made with our map in this case. And I'm going to call this vec. omap dot begin, and then omap dot end, and that's how we initialize our vector that we're able to call. For the next part, this part is going to be displaying by using a for loop, and we can use the same type of syntax that we did before, where we have int I equals 0, I is less than the vec.size, and then we increment the vector accordingly. Then we will output vec I dot first vec I dot second, because it's just going in a continuous for loop that we have over here, and then we return 0. So there we go. And so we've already done that. We retrieved one of the key value pairs that we were looking for explicitly, and then we remove a key value pair accordingly. And we are then able to display the rest of our hash table accordingly, even after removing 2 that we have erased in this case. So let me just zoom out of here, and I'll put this as well in the discussion. There we go. And now let's head over and do our second problem. And now let's focus on creating a hash table using an unordered map, or you can call this a hash map for the most part, depending on whatever context that you put it in. But the point in principle is this is what we have. So to be able to kick things off over what we have, let's go further in depth. So we will also include, after we include iOS stream, include unordered map. And then we will also include our vector, useful to be able to help us print out everything. And we will also include using namespace std for the sake of convenience. Then call upon the main function, and we will do an unordered map. And let's go with the string and int, much like what we did last time. And I'm going to call this umap. Now we're going to be doing the exact same thing that we did before. Then we continue the following. We will insert key value pairs, retrieve values by key, remove key value pair, and converting unordered map to vector for indexed access, and display the values. So what we will be doing is that to insert, we're just going to call upon this, and since we have a key value pair, what we will be doing is 1 is equal to 1, and then we'll do the same thing for the other ones as well, except for 2, 3. This does look like the other one that we have already done, except we're using unordered. Count value for 2. And this is great practice anyway. 2 end L, and then umap dot erase will be 2 here, and converting what we have to a vector so we can output pair string int. Then I'm going to call that vec, and then I'm going to put in umap dot begin, umap dot end, putting it there, and then we display the values by doing our for loop for int I is equal to 0, I is less than vec dot size, and then plus plus I. And we'll output our vector I dot first, vec I dot second, and we'll end everything by end L. And finally return 0 because we're working with an integer in this case. And so yeah, let's just clean this up and make sure it's running smoothly. There we go. Does the same exact thing over here, just like what we did before. And it's by general principle, feel free to take a screenshot accordingly. And then let's move over to our multi-map problem. And now for our unordered multi-map problem. So the first thing that we usually do, as usual, we include our libraries that we are going to call iOS stream. Include. This time we're going to be using an unordered map for the flexibility to be able to create a multi map, and then we'll also include a vector to be able to loop through the rest of our hash function or hash table per se, and then using namespace std int main right here. Now we're going to first redeclare unordered map, but we're going to call it multi-map. We're going to have string int u map. So we're using this multi-map from the there we go. We're using this multi-map from this library that we've already set in place, and going to first do our function is that we're going to insert, retrieve, remove, and then I'll display. So insert, the way we do this is going to be umap.insert, and for make compare, there we go, 1 and 1. And this is used for multi maps. So 2, 3, 4, 2, 3, 4, semicolon, semicolon, semicolon. Except for this time, we're going to be doing this. We will be, let's just take this 4, and this time let's call this 2, and this time use 22. So this is where multi-maps go in. Now the next part we're going to be doing is that we will retrieve. The way we're going to be doing so is that we will retrieve the values by key. And this time we're going to be using a for auto loop. So to do so, we go auto range equals umap equal range by 2. And then we're going to output values for 2. And then for auto it is equal to range dot first. It doesn't equal the range dot second. We're going to output. We're going to go through. So it does operate the same context for whenever we have a vector. In this case, it's just that we are getting the specific values that we need for our multi-map that we have for our hash table in general. Second here, or hash map. And then we'll finally have count end. Then the next part we're going to be removing, and we do so by umap.erase. And we can just call 2, so we'll erase one of the key value pairs. And then we will display by using our vector pair string int, and then vec umap.begin, umap.end, and then display. We'll use for loop for int I is equal to 0, I is less than vec.size. And then we increment with I, and then we're going to output the rest of our vector. So vector I dot first, vec I dot second, and L. There we go. And finally, since we have an integer for main, we will return 0. So let's build this to make sure this is all good. Well, it looks good right here. And now let's return. Yay, we did that. And it looks like whenever we erase 2, it actually gets rid of these 2 elements that we already have for integers. So they're all grouped together, and that's just the context for the multi-map. So feel free to take a screenshot for this exercise we have. And now let's move over to our sets. So the warning is really because this we need to make this an unsigned integer, so I'm going to call the size t in this case, so that way there was no constraint. There we go. And should work. There we go. Yep, it does the same thing, and we got rid of the whole warning. So yes, this is our unordered multi-set solution, highlighting the whole functions, and you folks can take a screenshot to be able to go further in depth and understand more at the same time. Let me just zoom in slightly. There we go. And so yes, this was the unordered multi-set. Hey everyone, thank you very much for taking time to watch this today. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.